Today we're gonna talk about SQL and DuckDB. So first we'll see what's a database, what's SQL, and then at the end we'll run some commands to DuckDB to understand SQL better. So before that, let's understand what's a database is. So database is just like a structured collection of data. It could be like different tables, and then table have different data sets, and those tables are related to each other. So that's an example of a relational database in which the data is in tables and the tables are interconnected to each other. And database comes in several different types. The first one is this relational database where everything is into tables, but there are other types of databases such as like graph linked database, which are called not only SQL, it's NoSQL, where the objects or tables are not tables, but the documents are arranged, let's say, into a JSON format where you have key and value pairs to arrange your data set. And specifically talking about SQL databases, where all the data sets are arranged into a table, into rows and columns, where the columns are different attributes of each row. So for example, here you see there are customers, products, employees, and orders. And in customers, you can have the different attributes. So this could be an example of, let's say, Amazon, where you have different customers and their attributes, their first name, last name, how much the money they've spent, and their anniversary. So that, let's say, you want to start some offer for them. So based on their anniversary date, you can pitch them. So, and then again, their orders, like what are they buying, and let's say if this is an example of a actual offline store, then you can have employees which are processing the orders, and everything will be linked into different tables where there would be some features or some column headers which are common across different tables. So for example, in the customer table, you'll have all the information about customers, but then there will be a orders table where there will be entries about what orders each customer is placing, and then there will be a products table which have information about what product is there, what's the price of that product, what category it is. Is it, let's say, a household product or a travel like accessory, something like that. So that's a database. And to query this database, or let's say to insert information or to get information out of the data set, or let's say you take information out, transform it, and then push it back to a database. So for that, you have SQL, which stands for Structured Query Language. And the literal meaning is that it's a programming language which is used to store and process information. And there are different kinds of SQL statements. The first one is DDL, which is data definition. So it doesn't really affect the data, but it affects how the data is arranged. So let's say you want to add a new table. Let's say you're expanding your store or some kind of functionality to your app, then you can have another table inside the database which will take care of the new functionality. Or if you want to clean something up and then you want to drop some tables, so then you can use this drop command. Another is data manipulation language, where you gonna look at so not affecting the tables, but the data inside it. So for example, let's say you want to insert a new entry into a products. You want to introduce a new product for your, let's say, your e-commerce website. Then you can use this insert command to have a row for that product, or you want to update, or so let's say you want to reduce or increase the price of something. So that's when you can use this update command to change the data inside your table. And then the most common thing which we will look today is the select command. So just today we'll just look at how to query data based on different conditions from your database. And to achieve all this, we will look at DuckDB, which is a relational database, and it is very fast because everything runs in the memory. You don't need anything like sophisticated architecture to set it up. Everything runs in the memory, and it supports native SQL queries, which we'll look at after some time. That like running a MySQL query is very easy. Just have to put it into like a DuckDB format and just run it, and then you get a like a nicely arranged data out of the database. So yeah, so today we will look at one example where the data initially was in CSV, and then I converted each of the CSV to a table, and then all the tables are inside this database. So how to convert that we'll look in the next workshop, but today we'll just look at how, let's say given you have a database, now how do you extract information from it? Yeah. So for that we'll move to Colab, and if you go to the wiki link, the Colab link is posted in today's workshop here. Open this link and click on this open in Colab. You should have it. Should we start? Okay. Yeah. So like I said, you don't really need to do anything fancy to have this data set or DuckDB import. You can just call it import DuckDB since it's available on Colab, and if not, it comes like a not simple pip install functionality. So if DuckDB is not there in your system, you can just do pip install DuckDB and it will be there. Since Colab already have it, so we can just do it import DuckDB here. So once I run it, uh, it just reloads DuckDB. And today we'll work with a synthetic COVID-19 patient dataset with 100K examples. And I provided a dataset link here. So if you go to this link, you'll see the CSV files. But since we are talking about SQL and not pandas, so I've converted all the CSVs into tables, and then all the tables are a part of this DuckDB database. So if you run the next command, or the next cell, it will just download the DuckDB database onto your Colab, and once it's done, you'll see a my underscore database.duckdb file. And once it's there, well, then we can start thinking about like what to do after you get access to the database. Yeah. Okay. Yeah. So, and then once you have this database name.duckdb file, you can use this duckdb.connect command to open a connection to this database, and we'll call it con. So yeah, now we have a connection. So before even before we start querying the database, we would like to know that what tables are in this database, because if you don't know the table name, you can't really get data out. So and the next command is how SQL commands are run in DuckDB, that you put the connection name and then put connection name dot SQL and put it into parentheses, and then put into strings, you put your actual SQL commands here. So if it were normal SQL, let's say MySQL, you would run like show tables or some kind of uh, like specific command relating to that SQL uh, database. But since we are using DuckDB, what we have to do is connection.sql and then show tables. And if you run this, it will just show you like what are all the tables present in this database. So you have allergies, care plans, conditions. And so this is just an example of how the data is arranged into a medical setting, where you have the patient's table, which has all the information about the patients, and then you have immunizations, medications, observations, and if let's say a patient is visiting a care center, then all of that information you would find into encounters.
question.
Yeah.
So with my background, I've not done tons of SQL, but the thing that I come across every time is that the syntax is always like these capitalized sections and then some parts that are not capitalized.
I don't think SQL doesn't really matter if you capitalize or not. Yeah, it's just like a preference. Yeah. Because once you see like I have show tables here, but in the next command I do describe patients. So I don't think it really matters.
So if you write those tables, the command for it, and patients is the name of the table, that.
Yeah.
But if you have to describe, that's a command.
Yes.
So
Yeah.
the commands are
Always.
capital.
Yeah, capital. Yeah.
It's like a sort of self-documenting style where you can tell you that's a variable and this is the now. So it's good to go with, but I guess I was just wondering about the history there.
Sure. And once, let's say we want to explore the patient's table, then we go and do con.sql and describe patients, and then now it describes all the patient, like not describe patients, but what are the different columns inside the patient's table. So you start with ID, birth date, death date, SSN, and then this is synthetic data. You don't really need to worry about what entries are there, just the schema of this table in the database. And the strings are denoted as like varchar, which is like variable character, and yeah, right. And then once you have the numbers, it's stored into a double format. Like for example, healthcare expenses, lat longs, all these are examples of numbers in the database. So yeah, let's look at another table. It's if we run con.sql describe medications. So now
And they described there was some type of cell, like so one is right. So, yeah,
maybe in the next tables we will have something.
yeah. Different now.
Yeah. So once we, okay. Yeah, so once we run the next, so just want to know like what's inside the medications table. We run con.sql and describe medications. Once we run it, we get to see, okay, now the command has output all the column names for this table in a very nice format here. And here now, once we know like, okay, what column names are there, we can start querying the data set. So before querying, like you should be able to like form a question and then try to translate it into SQL queries. So first we'll look at this example of select, and the select statement is used to select data from a database or let's say table. And the question is that query the patient's table and display patient's first name, last name, gender, and city. So initially we saw here that there are so many different column names are there, but like for example 25, but we are just interested in just knowing the 4 column names, like the first name, last name, gender, and the city in which the patient lives. So what you have to do is uh, run this, say select first, last, gender, and city. So select is the SQL command for selecting data, and then you have these 4 column names, the columns you want to fetch from the patient's table, and then you have from patients. So which tells SQL that, okay, go to the patient's table, look at these 4 columns, and then select them and show them. What's it? Yeah, once zip, yeah, zip. Yeah, one sec. Yep. So let's say we go here, we add zip. Yeah. Yeah. Yeah, yeah, variable, yeah, characters, and then you have double because it's a number, and if you don't see any entry there, it will just say null. So yeah, I have like it in like after some steps we have like how do we take care of null rows? Yeah, yeah, like it's yeah, and one thing here is that see it will just show like 20, but there are many rows inside the data set. What you just see here is like that. some like top 20 or something. But now if we have to know like how many rows are there, we have to go to the count command. So now it's saying count the number of rows in the patient's table. So if you run this query, it will just effectively give you the total number of patients, right? If you just do like con.sql, select count star, so just it's just saying that count all the rows inside the patient's table. Once we run it, so it says there are about like 124K rows inside the patient's table. Okay, now this is an example of count and distinct. So you want to count, but you just want to say like, okay, from how many cities your patients are. So this is a synthetic data set based on some study in Massachusetts. So all the cities are from that state. So if you run, say, con.sql and then select count distinct cities, so now it will put a distinct filter. So it will go to the patient's table, do a unique in terms of, let's say, numpy, do a unique on the city uh, column, and output the result says 351 cities are unique or distinct in this table. Okay, now if you want to know, okay, like city or gender, so this is like multiple now. So instead of distinct, you are doing distinct city and then do gender. So then you have unique combinations of cities and genders from the patient table. And once you run this, you have like all the cities here and you have gender. So assuming that there's like 351 cities and assuming male, female, both, you will assume around 700 from the like both types of patients from all the cities here. Okay, so next is, so once we have this normal querying function, but we want to, let's say, filter something. So initially we were only looking at the patient's table. We were pulling all the data together, but let's say now we want to filter this data on some specific value. So for that we have this where command, and the basic command remains same that you first select, but then at the end you put a filter that instead of all the cities in that specific state, you say where city equals Springfield, and now it will just output everything from the specific city here. So for this, if I want to know patient in the city equals Springfield, I put where city equals Springfield, and now I have all the patients from the Springfield city. And you can have multiple conditions in selection. So let's say if I want to know, so before we looked at like patients in city Springfield, now I want to look at all the female patients in city Springfield. So what can I do is select first, last, gender, city. These are all the uh, columns from which table, patient's table, and then comes our filters. It says where equal to city Springfield, and then we say and, which means that, okay, look at Springfield, but then also look at this another condition where gender matches female, and then return it.
The where is that fit with distinct?
Yeah, it can.
Does it go inside of the?
So distinct comes after the select. Yeah. So here you are defining. So in the next workshop, we'll look at what's like the structure of SQL queries. So let's say you write something. So what's the first part which gets executed, and then the filtering is done. So first is the from patients, then it will do filter. So then where will run, and then once it runs, it will output this first, last, gender, and city. And let's say if you want to, let's say distinct, do a distinct, let's say on a last name. So you can do a distinct here where people will who have just distinct last names. So if somebody is from like one family, only one member will show up. Yeah. Okay. And so the next example is about doing a nested selection. So let's say instead of Springfield, you want to look at patients who are in Springfield, like either in Springfield or in Boston, but again, female patients. So you can do this kind of encapsulation inside those like parentheses, say city equals to Springfield or city equals Boston. So this becomes your first filter, and now it's paired with your gender equal to F. That's your second filter. All combined together gives you a table of female patients from both the cities. And
How do you know this? About it? Keep me not before push me here. How do you know this?
so I think you can do like not in or something like that.
Say, say, city not before push me.
I
Have it.
Yeah, so not explanation, but it's like it's like not in. So if we see the next command, let's say, so another way is that we use this in, city in, and then you again show like brackets and put it like a Python list, but don't put like the square brackets here. So let's say if you do like not in Springfield or something, then it will just show all the results together.
Strictly a negation operator that.
Yeah, I think it's like not in or something. Uh, Yeah, because we will see one in the next part where we do missing data filtering. So now we filter on missing data, and I've just put it like why missing data is important, that sometimes you have to like include or exclude missing data. So there are commands which will help you to look at like missing data. So the first one is that retrieve the first name, last name, gender, and city of all the patients who are from Springfield and have a passport number recorded. So, which another other word is that the passport field is not empty. So what you can do is put the same command here and just at the end say and passport is not null, which means that return all the rows where there is at least some value in the passport field. So once you run it, you're gonna have all the patients from Springfield who have a passport number recorded. And what we can do is if you go above and check how many patients are there in Springfield, so it says like 2814. And once you have the passport number, it says 2221. So this gives an indication that like there are some people who don't have a passport number. So what about it? So if you go and run the next and say where passport is null, it will give you all the patients with these specific characteristics, but there where the passport is null, which means that there's no value present in the passport column of these patients. And just as a sanity check, if you do like with passport and without passport, it should match the actual number of the patients in Springfield. Okay. Now this example brings in, so initially we were just doing filterings on string values, but here we are filtering on numerical. So you can club both number-based filtering and string-based filtering in the next command. Yeah, so you can do anything like more than or less than equals to, not equals to. Yeah. Yeah, and so so for this example, let's say our question is find all the patients in the city Springfield where the patient's healthcare expenses between 1.5 million to 2 million, and then you say, so we looked at till this point that where city equals to Springfield, the next and then the what you need to add is add healthcare expenses between and just put the number. So it will do a filter on healthcare expenses, see if the value lies in between this range. Yeah, and then once you run it, you have all the patients here. Yeah, I mean, you can also look at like just copy health expenses here and run this. So it will also give you the health expenses. So you can just verify that whatever range you put is actually present inside the column. Yeah. Yeah. So next we'll look at limit, and limit will return, so whatever you put after limit just returns you like the maximum number of records. So this, so there's like a bigger query, but you just want to see how it how it is arranged. So this is like another way that instead of, let's say, doing describe a table, what you can do is select star from the table and just limit to 1. So that will just give you like one example out of the table, and it will show you all the schema that what column names are there with just one example. Yeah, so that's another way of looking at table information.
I like it.
Yeah, yeah. Next is order by and ascending. So let's say you filtered your data, but now you want to look at into an ordered manner. So next is, let's say the query is that retrieve the first 20 patients, and but order their name, or order them by their last name. So you select all the 4 columns from patient, but then again put another snippet of code which says order by last. So order everything by last name, but in ascending order, and then limit by 20. So once you run this, it just sorts the rows based on this last column. So Abbott 774 is like alphabetically is on the higher side. So yeah, and then you see like all the Abbotts are there. Yeah, and you can do the similar thing with descending. So instead of saying uh, order patient by ascending, you can say order by first. So now instead of last name in the previous cell, we are now looking at the first name, and we are ordering it into a descending order. So now for the first name, this Oscar and that O with like a special character is there. So instead of Z, probably you'll see like an Oscar with that special character. And then again, we limit it to 20. Okay, so this was all about like filtering dataset. Next, we'll look at group by. Yeah, grouping just to look at what summary statistics are available. So for example, let's say the question is that we want to know out of our like 128K something patients, what's the distribution of patients in each city? Because we already looked at there were 351 cities inside this table, or for the patients table. So what we can do is select city, and then we do a count on star, and then and we say count. So this as command is like whatever you put it here, and so whatever that count star is, it will go to, and it will get assigned to this variable patient count. And you have the select city and then count star as patient. So whatever count you will get saved to patient count, and now you have to look at patients table and group them by city. So now once you run this, you'll get like that there were 351 cities, we have it, and then this is the patient count here. So this command was able to give you like, okay, out of all your 128K patients, how many of these patients belong to different cities here? Yeah. And once you run it, it's like gives you random order. So like right now, Springfield is at the top, like we saw 28, 14 patients. Now I run it again. Yeah, it's in the next part, like, yeah, like counting patients by city and then sorting them from highest to lowest. So what you just have to do is again do it like an order by. And why we are doing order by in this variable name? Because we are saving the count star into the patient count new. So we have defined a new variable saying that, hey, SQL, this is the variable in which store all the counts, and then do a order by on this patient count and descending, put them in a descending order. So once we run it, we have all the cities here, and then it's like obvious, right? Like Boston is populated, lot of people live there. So you have like what, almost 11,500 people living in Boston. And there are cities in which there are like people that less than 10 people living in each city. So it kinds of orders this. So let's say if you had put ascending here, so it would just put it in the reverse order. Now these cities like Monroe or Birmingham goes to the top. Yeah. Now we will look at like order by group by two conditions. So initially we looked at city. Now we look at group by city and gender both. So we have to put, again, it's very similar. You just do first select, and again put your count star as total patients, and which table, patients table, and group by city, gender, and then order by total patients and descending. So once you run it, it will say okay. So now you're looking at, so in the initial command, we looked at Boston, which has like what, 11,496. But in the next, once you run it, you'll see, okay, Boston is there, but now you have Boston divided it into the on genders. So same goes for like other cities as well. So the second one was this one, and then there was Springfield at third. So you looked at Springfield, and then now you have both male and female in Springfield. So like, let's say if you don't limit by 10, it will just give you all the cities and what's the distribution of gender in these cities. Yeah, now we are looking at another table because next topic is joins. So we are just trying to see what's in the observation table here. So again, same command to just to know about the observation table is describe observations, and then you have all the different columns: date, patient, encounter, code, description, value, units, type. All these are attributes related to this observations table. And observation in clinical setting means, let's say if somebody's like trying to make a measurement, or you have, let's say, a blood sample which is being processed in the lab and the results come out, let's say vital signs. Somebody in ICU, they're constantly getting monitored. So, and then the information is getting into this database. So all these information is available in the observations table. And like, for example, let's say we do a selection where we say patient, encounter, code, and description, and its value. And once we run it, so we get like, there are so many observations, and all the patients have these unique IDs, and the encounters have unique IDs, and all the description have their code. And for this patient number, this 1FF something, they have their all body height, pain, body weight, and a value associated with that here. And then like all different, let's say respiratory rate, heart rate, blood pressure, so and so forth, so many values. So, and this is useful. Let's say now you want to query your maybe high risk patients based on this database. So for example, you want to see what's the average heart rate by patient. So there is, let's say there is some patient, you get multiple heart rate values because they are in constant setting where people are monitoring, getting some information out of them. So for all those values available for that one patient, let's say you want to see what's the average heart rate. So what you do is, first we'll start again with what's the table we have to define. We go from observations table, right? And then where we want to look at, we filter it using the description. And what should the description look like? It should look like this heart rate. So if you go above, you should see that that's how heart rate looked like. So that's like a string matching thing where you can match whatever you want to see with the description here. So now it will match everything, takes up all the rows with this heart rate variable. And then next is group by. So once you get all those heart rate values for all the patients, you do a grouping. And how do this grouping as uh, this command which says that cast whatever values in the heart in the value column, round it off, do an average. Oh, first do an average, then round it off. And once you do this, put it into this average heart rate variable. So that's the flow of processing in this SQL command, that look at the table, look at the column name, match the string with the column name, get the rows out. Once you get the rows out, group it by using patient name. How do you group it? Using the mean of all the values available. Once you have it saved as a heart rate, you do uh, what do you call sorting based on this heart rate variable in a descending order. So once you have this very complex query, you'll see, okay, you have the results that these and these many patients have like an average heart rate of like 200. So maybe these are some critical patients inside the database.
With that first example of a man that's this long, my question is more about how you develop and test these things as you're typing them out. Do you find yourselves working mostly like identify the string that you care about, and then think about the metric, like your average and then think about how you're gonna group after that, or?
Yeah, I think it's like just, so I think how I wrote this is I look at the question and then say, okay, so if I want to see heart rate, which table I'm going to look at? And then once I have the table, I just did like a small view of that table that, okay, these are the description variables inside. Or the other alternative is that you do a unique on description so that you have all the attributes available. And then you try to see, do you want to look at heart rate or do you want to look at something else? Yeah. Yeah. Once you have it, then you look at the value that like, okay, there is an attribute heart rate, but what value is there? What do you want to do with value? I mean, another question is that given all those values, what's the max? So it will just find that during any time point, if there was some maximum heart rate somebody achieved, then you can filter based on that. Yeah. So
Yeah, and it's sort of, it'll be fun to sort of mess around and see how that
yeah,
iteration.
yeah, and this looks clean, the result, because of this value as decimal 10, 6, and 2. So it's like count this value as decimal and then pre-process it, and then you have round it off to just like some float, some point after the decimal. And so, and then you can save this as average heart rate. So this is like too much here to understand, but my point is here that if this is just like you want to group by patients on something new feature which was not there in the original table. So you defined this average heart rate, uh, which was not there, and then you group the patients together.
Since it's a read-only table, that average heart rate column only exists at the end of your query, right? Like, it doesn't get committed.
You can save this at the end, let's say, and like, let's say you write a very long query, it takes a lot of time to run. So what you can do is you can save that so that you every time you have to query that, you don't have to spend like 10 minutes running something. You have it saved somewhere. Yeah. And another thing is that let's say it were not a read-only database, then what you can do is once you have a new looking table, you can push that table to the database. Yeah. So it becomes like a derived database, but still the patient ID remains same. So this table, whatever you save, will link to the original. Yeah. Okay, next is how many heart records are there for each patient. So instead of like that round thing, because we are not taking any average here, we just want to know the count. So instead of saying, okay, round, cast this value, this and that, we can just do like count star. Yeah. Yes. And the rest of the things goes the same, that okay, for this patient, there are like 33 heart rate records available. So let's say if they did it for like every day, the patient was in under observation for like 33 days, something like that. You can't be sure because there are always like missing values. So, but then you can have an estimate that, or if they are doing it for, let's say, every hour, then like the patient was there for like 1.5 days. So, yeah. Okay, now we can look at another table. Yeah, so before we go or move to the next cell, one thing I would like to make clear that these tables look very bad. I mean, there is like a patient ID, and this patient ID is like, it looks like like a unique identifier, which doesn't make any sense. So what you ideally want is that the patient name, but the patient name is not here in this observation. So then the next part comes at the how do you put patient names here? And that's where join comes in. So let's look at another table where we look at immunizations. So we run a con.sql, describe immunization. So now again, it will just give you the table schema that what are the different column names here. Again, we do a simple query that select all the patients, and counter code description, what's the cost of immunization. It will give you just a list of everything. Yeah. Now again, we are just doing a group by all the same command we looked before, but on a new table. So if we run this, and say what is the base cost for each patient for all the immunizations a patient got. So for each patient you're looking at, for all the immunizations happened to the patients, what is the base cost, or like what's the total cost? So what you're just doing is like summing everything for one patient here and then putting it into another table. Yeah, yeah, yeah. Now comes like some queries that if you want to know that, let's say you have all these vaccinations, but what are like the most common vaccinations administered into the patient. So once you run it, you see that, okay, this like the flu vaccine is the most common one, and then you have like the different types of vaccines here. Yeah. So this was all about normal querying data set from like one single table, or making a summary of the table based on different values. Now we can look at joins here. So joins are used to combine rows from one or more table, and there are like several different types of joins. We'll cover each one of them. And it's possible that if you want, so by two tables, I don't mean that the tables need to be like different. That's where self join comes in, that you can still have the same table and join it to kind of see, okay, which rows are related to each other. Yeah. So next is inner join. And for each example, we'll consider that your left table is your patient's table and your right table is immunizations table. And what is inner join? Inner join is that if there's like at least one match in both the tables. So if there's like one, whatever you are doing a join on, let's say the join query is on patient ID. So now it will look at patient's ID in the patient's table and then patient's ID in the immunizations table, and then whatever common IDs are there, it will just output it. So for example, the question, let's say you want to ask is which medical treatment have been administered to patients, and now you want to include patient's name and cost of each treatment. So that's where the join comes in. That earlier you had some example of tables, but you didn't know what patients are there. This ID doesn't mean anything to you. And this patient information is available in the patient's table. So you did a join between patient's table and immunizations table to fill this column.
Oh, yeah, so that unique ID is sort of like overlap.
Yes. Yeah, that's the relation. That's why these are like relational databases, because there's that unique ID relates to two tables. Yeah, using that unique ID. I mean, if there is no unique ID, then I'm not sure what you can do, but there has to be something common between those two tables to do a join. Yeah. So first, again, we start here. It says from immunizations to an inner join on patients on like which column, which IDs. So for you first pick immunization.patient. So that's your column name in the patient's ID, and no, the column name in immunizations table, which should match with your ID column in the patient's table. And once these match, you do a join, which kind of join? Inner join. And once you join those tables, these are the two or the four columns you want out. So the first one is for patients.first, patient.last. So these are coming from the patient's table. And now you have these immunization description and immunizations base cost, which is coming from the immunizations table. Once, and when you do the inner join, it just finds the common IDs between those two tables and shows you here. And how you're ordering here is that you are just doing a ascending filter on the patients. So you have all the patients arranged like from their start from Aaron to Ariel and so on and so forth. And now you have different descriptions for their vaccines here. And what's the base cost? Okay, now we can look at left join. Left join is, so remember our convention. Our left table is patients and right table is immunizations. Now I want to look at return all the rows from the left table and the matched rows from the right table. What this means is that for all patients, tell me what treatments or not treatments. Maybe I mistyped it. Yeah, what immunizations have they received, if any? So now same thing, but now instead of do an inner join, what you do is like a left join. So that's how the command is. From patients, do a left join on immunizations. Then you match those keys here. Once you have those keys, select these columns and then at the end order by patients dot first in ascending order. So now we have again RN697 arranged here, and the immunization they got, and that's the cost. Now looking,
Sure about the difference between these. Can you say it again? So when we have left join.
yeah, it's yeah. So I have this table. So you see inner is like all the common rows between those two tables. But left join is like take all the rows from the left table and also the matching ones from the right, so that the intersection of these two tables is the matching from the right, but but give this information for all the rows in left. So for all the patients, give all the immunizations available.
That helps later. That's the query where you can actually refer to the patient table.
You can like, I mean, you can filter it out. Just say that, okay, for all the patients, you got something, right? Like, and next comes the right join where you see, okay, it's like saying that these are my list of immunizations, and now which patients got them. So now the patient's number will reduce.
Right.
Yeah, in the right join. In the left join, the immunizations will get reduced.
Yeah, like we have less.
Yes. Yeah. Yeah. So again, the right join is again saying for all, because our right table was immunization. It's like for all immunizations recorded, which patients received them, if there is an entry available. So now you can say that instead of this, like looking at the patients, now we are looking at the immunizations, and now we are ordering immunizations by description. So we have like different immunizations available here and then patients here.
It's helpful to have that sort of for all that comes first, and that's usually the larger piece.
Yeah.
Table of work. And then the next one is sort of like the subset of the other.
Yeah. I mean, it's possible to do the other way around. Like, let's say you assume that your left table is immunizations. So now the same information you got by putting it on right, if you consider it left, you do a left join, you will get the same information. So
Yeah, that's why I think I'm a little still confused, because, you know, in what case does one type of join do something that the other type wouldn't have let you do? I think is where I'm getting confused. They're each unique, it seems like, but I don't quite understand exactly what type of query you can only do with the right join versus.
yeah, so you can still run the query, and if you don't see a matching result, it will just say it doesn't exist.
Yeah.
Because that's what it says here in the right join, that for all immunizations recorded, which patient received them if identifiable. So if not, then you don't return it. Yeah, that's why the number of patients will get reduced here. Right. Yeah, and in the next join is like full outer join. So full outer join means when there's a match in one of those tables, you just combine both left join and right join. Yeah, so again, let's look at the Venn diagram. So it says, okay, that's like the full join. That just gives you all the rows together for both the tables here. Yeah, so and the question you can ask is like, what is the complete list of patient and their immunization, including those without recorded? So it will also include the patients which don't have immunizations. Wait one second. Yeah. Because like you see here, there's like a null here. So for this person Antonio Low, it didn't found anything, but still it's in the entry because that's why it's a full join. It will just return you all the rows. Yeah, again for like this guy RN 563, you have a null here, which means that okay, there was no entry found in the immunizations table for this guy.
So if we were trying to do something like, let's say right now we have base cost. It might be a query that you would do a full join if you wanted to be able to report, I have estimates for these types of vaccinations, but then I also have an entire category of people who don't have vaccination information, and only from the full join could you
Yeah.
put all of that into a
Right.
file.
So what you can do is like do a filter on description, say null, not null.
Yeah.
You get two tables, and then you can do a summary query on the base cost on the table where you have this information available. Yeah. 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 Next is cross join. I'm not sure when this is used, but sometime it will not make sense that because it's just saying that all the rows are here in the left table, all the rows are in the right table. You can just do a mismatch, mix and match of all the things and make a table, because that's where you will have chance of like having a big table where there's like so many repeated values here. So yeah, if I find a good example, then I'll show it in the next tutorial. But yeah, next is self join. Like we talked about it. It's not like a different type of join. It just says that if you want to compare rows within the same table, that's what you can do here. So let's say the question is which pair of patients are from the same city. But that's again like a not a good command, because now you are just looking at two patients, and then there could be like, let's say there are n patients, so the max could be like n minus one pairs of match, n minus one divided by two. So that's the number of rows it can become like very high. So there is an aggregate operation which uses a function on string, which we'll look at in the next tutorial, that instead of doing like a self join, it can look at rows and then it will just club patients together based on their city. Right. And yeah. And I have like some more examples of join, like what are the cost of total immunized per patient. And then we have like now you can do a filtering in joins based on some date, that what treatment were administered to patients in year 2020. So you do the same stuff with a right join, but then you have a date filter and then you order this immunizations here. Yep. And next, and the last example we have for today is we talked about doing joins on two tables, but now if you want to look at three tables at once. So the question you may want to ask is, for all the patients who have received an influenza vaccine, what are their lab results for cholesterol tests? So patients information will come from patient's table. Vaccine information will come from your immunizations table, and cholesterol information will come from the other table, observations, where you have the lab results. So it's like saying you have like three circles, like a three-way Venn diagram, and you're trying to extract information. So that's how you can do is do like join after join for three tables, define those column names and run it. So that's how you can get like all those patients with who got influenza vaccine and who has a cholesterol lab result available. Those values, and you can have like, okay, do a sort on some kind of date. So you can also extract the date also, like given a time period or something. So, and you can also order it on multiple conditions. So now you do on first, like on last name, and then on first name, and then on date. So it will just first order all the last name columns, then go to the first. So you will have like last name arranged, and then so like first you have A in the last name, then it goes to the first name arranged from A to Z, and then it goes to the test date. So that's why you have like 2020 mentioned here for patients whose name starts with A. So yeah. Yep, that's it for today.